Dear students, under the lecture series on complex analysis, we are solving problems under Taylor series. Here we have the first problem. We have to expand f of z equal to 1 by z into a Taylor series expansion about the point z equal to 1. And also we have to determine the regions or region of convergence. Now first we shall expand f of z equal to 1 by z into a Taylor series about the point z equal to 1. For that, first we have to write the Taylor series of f of z about the point z naught. So by the theorem on Taylor series, we have the Taylor series of f of z about the point z naught is given by f of z is equal to f of z naught plus f dash of z naught by 1 factorial multiplied with z minus z naught plus f double dash of z naught by 2 factorial multiplied with z minus z naught the whole square. And the general term will be fn of z naught, that is the nth derivative of the function f divided by n factorial multiplied with z minus z naught the whole power n plus etc. So this is the Taylor series expansion. Now for the given function f of z equal to 1 by z, we have to find the Taylor series expansion. And this expansion is possible only if f of z is analytic function. So we that is analytic at the given point, that is z equal to 1. It has to be analytic at this point. Therefore this Taylor series expansion can be applied. We already know that f of z equal to 1 by z is an analytic function. Now let us expand this by using the Taylor series. Now here in the given question, f of z is given to be equal to 1 by z. And what about z naught? Z naught is the point about which we have to find the Taylor series. We have to find about the point z equal to 1. So therefore z naught is equal to 1. Now in order to apply in this expansion, we shall substitute f of z as 1 by z and z naught as 1. So the expansion, how it becomes? It becomes, for f of z we have to write 1 by z is equal to f of z naught. So it will be f of 1 plus f dash of z naught, which means f dash of 1 divided by 1 factorial multiplied with z minus z naught, which is z minus z naught is what? 1, plus f double dash of z naught divided by 2 factorial multiplied with z minus z naught is 1. So the whole square. We will write the third term also. So that will be equal to f triple dash of z naught. The third term will be one, two, three, fourth term this is. But after double dash we will be having triple dash. Divided by, it will be 3 factorial multiplied with z minus 1 the whole power 3. And then plus etc. It's a power series expansion, so we can write it. We need not write the general term. So first 4 terms I have written plus etc. So now if you see, in each of these we have to find f of 1, f dash of 1, and this is f double dash of 1 actually. Z naught is 1. Similarly f triple dash of 1. We have to substitute 1 here because z naught is 1. So it goes on like that. So these values we have to find. In order to find that, first we should have the derivatives of the function f. Now the function f is what? F of z is equal to 1 by z. We need f dash of z first. So f dash of z is the differentiation of f of z with respect to z. So what is the differentiation of 1 by z? We know that z has to be raised to the power minus 1. So it will be minus z to the power minus 1, which will be z power minus 2. So it can be written as 1 by z square. And obviously we know that the differentiation of 1 by z is minus 1 by z square. And what about f double dash of z? We have to further differentiate this. Actually this can be written as minus z to the power minus 2. So on further differentiating it, it will be minus multiplied with minus 2z to the power minus 3. So therefore it will be minus into minus becomes plus 2 divided by z cube. In a similar way, let's find f triple dash of z also. So that will be equal to, so actually this has to be differentiated further. So the minus into minus is actually 2, and this is minus 3 z to the power minus 4 you will be getting. on differentiation. And so that will be equal to, when you multiply, it will be minus 3 2 times is 6 divided by z to the power 4. So after obtaining this, actually we need f dash of 1, f of 1, f dash of 1, f double dash of 1 and f triple dash of 1, etc. So from this, what will be f of 1? So if you see from this f of 1, so at the place of z we have to put 1. So we will be getting 1. And from this, what will be f dash of 1? It will be equal to, so in this we have to put z as 1. So 1 square is 1 only, so it will be minus 1. And from this we have to find f double dash of 1. So this is 2 by 1 cube, so that will be equal to 2. And from this we have to find f triple dash of 1, which will be equal to minus 6, because 1 power 4 is 1 only, so it is minus 6. So it keeps on going like that, but we have certainly stopped with 4 terms. So we have found this, and let us substitute all this over here. So now let us substitute whatever we have found. So here it will be 1 by z is equal to f of 1. F of 1 is what? 1. So let us substitute that. So 1, and then plus f dash of 1 by 1 factorial. What is f dash of 1? It is minus 1. So minus 1 divided by 1 factorial multiplied with z minus 1, plus f double dash of 1 is what? 2. So 2 divided by 2 factorial is 2 only, and then z minus 1 the whole square, plus f triple dash of 1 is what? Minus 6. So it will be minus 6, and 3 factorial is 3 into 2, which is 6, and z minus 1 the whole cube, plus etc. It keeps on going like this. So the 6 and 6 gets cancelled, 2 and 2 gets cancelled, and on simplifying we get 1 by z plus 1, and this is minus, 1 by z is equal to 1, and then plus into minus is minus z by 1, and 1 factorial is 1 only, and then plus z minus 1 the whole square, and then minus again, plus into minus, so minus z minus 1 the whole cube, plus etc. So this is the power series, that is the Taylor series expansion of the given function f of z equal to 1 by z. So after finding the Taylor series expansion, we still have the problem. It's not complete, because they have asked us to determine the radius region of convergence. So we have to find the region of convergence. So first of all, we should know what is region of convergence. So the region of convergence for a Taylor series is the distance from the center z0 to the nearest point where the function is not analytic. So that will be the region of convergence. So I have just put that into words. And how do we write the region of convergence? So the region of convergence, how we should write it? Modulus of z minus z0 lesser than r, where this z0 is the center point and this r is the radius. So this will give us the region of convergence. Now in order to write this, we should know what is r. We already know what is z0. Here we are finding z0 at 1, because we know that z0 is 1. Now r is the question. So what is r? The radius. So how to find that? It is the distance between z0 and the point where the function is not analytic. So let us, we know that the function f of z equal to 1 by z is analytic everywhere except at the point z equal to 0. So at that point it is not analytic. So now in order to find the radius r, we have to find the distance from the center 1 to the point where it is not analytic. So how to find the distance? So we have to find the distance from the center z equal to 1 to z equal to 0, and we know that the distance is the modulus of 1 minus 0, because that gives us the distance. So because since z is equal to 1 and to the point z equal to 0, so modulus of 1 minus 0, and that will be equal to modulus of 1, which is equal to 1, and that gives us the radius r, which is equal to 1. Now we shall substitute in this. We shall substitute z0 and r in order to find the region of convergence. So therefore the region of convergence is in this modulus of z minus z0 is what? It is 1, which is lesser than r. R is 1. So this gives us the region of convergence. Since this is the first problem under the Taylor series expansion, to find the region of convergence, I have written in detail for your understanding. So in future problems, we can just make use of these concepts to understand, and directly we can write the region of convergence. So therefore we have found the Taylor series expansion of the given function f of z equal to 1 by z, and also we have determined the region of convergence. So therefore we are done with this problem. I hope you have understood this concept. For more problems under this concept, follow the upcoming video lectures on this topic. Thank you.